Hello students, pleasant greetings to you all. Welcome back again to another video tutorial lesson from the AP3X Institute of Applied Mathematics. My name is Akin, your math instructor. Of course, primarily this channel focuses on assisting students in and around the Caribbean with the Caribbean Examination Council curriculum, C.XC, that is C.XC, C.C.SLC, and or SEA exams structured type questions. Of course, I primarily focus on assisting these students with preparations for their January exams and their May-June mathematics exams. Of course, if this is the first time here on the channel and you find the content useful, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and of course, if you do enjoy the content, do not forget to hit the like button. It really does help the channel to grow. So of course, we are back at it again with yet another tri-weekly exam. It is in fact the third of a 4-series tri-weekly exam review. This video is a little bit late, perhaps by a couple of days, because this particular quiz here was already administered about a week ago, so a lot of my students would have already attained their results. And safe to say that they didn't do as well as I expected them to. They did make a couple of fundamental mistakes. Consistently, they have been making fundamental mistakes. So I find it quite useful that I really should come here and give these students an opportunity to see where they went wrong and what approach they could have taken in order to attain maximum or a high enough mark to pass this exam. These questions are in fact structured by me. I did not copy and paste any questions. These questions were structured by me here, and I felt like it gave the students a really good opportunity to think outside of the box. And I did find also that the questions were well rounded. It touched a little bit of the areas that we've been practicing. Of course, you're seeing here on screen various questions coming from, say here, fractions, decimals, questions, worded problems, percentages. You're seeing questions here from variation, direct variation, ratio, algebra, and of course, unlike the previous tutorial here, we have dropped in 2 new topics here. We're looking at, in fact, the introduction to coordinate geometry, and of course, we've dropped in a little bit of measurements. So this is poised to be quite an interesting video. Do students, if you have your exam results in hand, ensure that you are looking at your paper and you're looking directly at the mistakes that you would have made, so we can move forward and be more efficient in our upcoming end of term exam. So without further ado, let's jump right into the video. And as I said before, hit the like button and do not forget to subscribe. Of course, share this out to all your other friends who you think might find this a beneficial tutorial. Alright, so let's jump right into the lesson. Here we go. So of course, traditionally, the instructions are as follows. Answer the following questions and show working where necessary. Of course, my students were allowed to use calculators. So of course, traditionally in paper 2 of the exams, you are allowed to use calculators. So let's get into it. All right, so our first question here, which has a maximum value here of, say here, 4 marks, we were asked to evaluate the following and write your answer in the lowest term. And I did find that quite a bit of the students who attempted this question, I think it ranges around the 60-40%, where 40% of my students are still making fundamental errors when it comes to fractions. So let's get into it and see what would have been the best approach to approach not just this question, but any fraction questions coming forward here. Alright, so what we have here is in fact 4 and a third, take away 1 and 5/6, all divided by 1 and 3/7 multiplied by 1 and 2/3. And of course, I always encourage my students to approach these types of questions in parts. You want to give your question a label. So here I want to label the top part here, say A, and I want to label here the bottom part here, say B. But before I actually go into the actual calculation, what I like to do here is that I like to convert all my mixed fractions, say here, to improper fractions. We're going to get right into it by saying here, say 3 multiplied by 4 is in fact 12. 12 plus 1 is in fact 13 over 3. Take away, say here, 6 ones. 6 plus 5 is in fact 11 over 6. All of that then will be divided by the result of the conversion at the bottom, which is in fact 7 ones 7 and 3 is 10 over 7. And of course, say here, multiplied by 3 ones 3 and 2 is 5 over 3. Now that we have everything converted to an improper fraction, then the next thing that you want to do here is in fact take your question in parts and transfer it, say, up here. So what we have then is in fact 13 over 3, take away 11 over 6. And this calls upon you remembering that when you're adding and subtracting fractions, you have to find what is known as the lowest common multiple. Now, I did find that quite a bit of my students, they used a multiple as opposed to using the lowest common multiple. When you use a multiple, what you're doing is that you're giving yourself additional work and you're working with bigger numbers than you really have to. So you want to always zone in on what is the smallest number that 3 and 6 can go into. And now in this particular question here, you'll find that 6 would have been the lowest common multiple. Yes, 18 can be used, yes, 24 can be used, but 6 would have been a far easier number to use. So here we say 3 into 6 goes, say, 2 times, multiply the top by 2, and 6 into 6 goes, say here, 1 time, multiply the top here by 1. We then proceed then to say 2 times 13 is in fact 26, and 1 times 11 is in fact 11. So therefore we end up with a result here of 15 over 6. Now I did also find that quite a bit of students, they did in fact carry this result of 15 over 6 down to the latter part of the problem, and whilst that is okay, I find that it's so much easier working with smaller numbers as opposed to larger numbers. And what do I mean by that? When you have a fraction like this, you want to always check to see if there's anything that can reduce this fraction to a lower form. And here you can see that 3 will be able to go into 15 5 times, and 3 can go into 6, say here, 2 times. So I think it's far more efficient to work with 5 over 2 as opposed to working with 15 over 6. So we're going to be holding on then to that particular answer here, and then we're going to be working then now the bottom part here, which is in fact 10 over 7, and that's going to be multiplied then, say here, by 5 over 3. So what you're going to find here is in fact at times we're always looking for something to reduce the fraction when it's multiplication. I did find quite a bit of students who are trying to find the LCM when we're multiplying. I'm not sure if it's lack of concentration or it's a lack of preparation, but just as a reminder, once more, ladies and gentlemen, boys and girls, we do not find the LCM when we are multiplying fractions. What we're looking for is looking for a way to reduce the fraction. Now in this particular example, we cannot, or we don't have a common factor here. 3 cannot go into 5, 3 cannot go into 10, 7 cannot go into 10, 7 cannot go into 5. So in this case here, when you end up with a situation like this, what you're going to find yourself doing here is in fact just multiplying the numerators with the numerators and the denominators with the denominators. So you'll find here that 10 times 5 is in fact 50. And of course 7 times 3 here is 21. And this will happen occasionally when you don't really find a factor to, say here, simplify the fraction. Now this fraction bar here that I've pointed with the arrow here means division, and so whatever answer that we have garnered at the top, which is in this case here 5 over 2, will be divided by the answer that was calculated at the bottom, which is then in fact 50 over 21. Now when we are dividing fractions, what do we do then? We simply change the division sign to a multiplication and we invert the divisor, or we say invert the fraction that appears immediately after the division sign. So we end up with, say here, 21 over 50. All right, a lot of teachers will say change sign flip last. That also works as well. So once again, we are back at point B here, where we were still looking for something to reduce the fraction. In this case here, 2 cannot go into 21, but 5 can go into itself 1 time, and 5 can go into 50, say here, 10 times. I do apologize for that. It goes 10 times. So then we end up with 1 times 21, which is 21, divided by, say here, 2 times 10, which is in fact 20. And a better answer would have been, say, to convert this to a mixed fraction, which is then 20 into 21 goes 1 time, remainder 1 over 20, and then that there would have given you a solid, very, very solid 4 marks for the exam. All right, so I do hope that with this little explanation here on fractions, you can then move forward finally then with always getting maximum marks on your fraction question then. All right, let's move on then to question say here part B. Now, I did find that if those students were given the opportunity to use a calculator, and believe it or not, you have students who are still making fundamental errors, such as ignoring the PEMDAS rule. Some students know it as BOMDAS, some knows it as BOMDAS, some knows it as BIDMAS. I teach my students PEMDAS, right? Some students know it as GEMDAS, but I particularly prefer PEMDAS as an operand, as an operator, as a mnemonic. Now, I did find that, again, a lot of my students started off the problem by working the questions from left to right, and that is completely ignoring the PEMDAS rule. Now, just to assist you for the third time when it comes to these types of questions, I advise my students that when you get questions like these, always write above the question the mnemonic, the abbreviation PEMDAS. Let's take a look at what I'm actually saying here. So what we're looking at here is in fact writing, say here, P E M D A S. And what you want to do when you have when you take this more strategic approach to it, what you're giving yourself a chance to know exactly what I should do first. Now you're gonna ask yourself, are there any parentheses in the question? Are there any brackets? Are there any operations that I need to do that is in a bracket? If there isn't any operation that has a bracket here, then we can simply cross off P. Then we're going to move to, say here, E. Are there any exponents that I need to simplify? It so happens here that there's one exponent here. And so what we're looking at then is in fact just simply rewriting, say here, 85.18, take away 3.26, and then I'm going to be working on what is 2.16 squared. And why I recommend that you do this for the fundamental students who are not as advanced, where you can do 2 things at the same time, I do recommend that if you want to ensure that you collect your marks, you want to work this problem out step by step. And so 2.16 squared works out to be 4.6656. We could round that off if we wanted to, divided, say here, by the sine of 87. Again, if you wanted to go ahead here and calculate sine of 87, we could just go right ahead. As opposed to writing it back down, we could go ahead there and find the sine of 87 at the same time here, which is works out to be 0.996. I particularly like when my students use 4 decimal places. All right, I particularly like that. It gives me a more accurate answer. So now that we have taken care of our exponent and we have taken care of this conversional trig function here, we can therefore cross out the E. Now we're going to be moving on to the M. Are there any multiplications to be evaluated here? And it so happens that we have to multiply 3.26 by 4.6656. So we're going to rewrite 85.18, and we're going to take away the result of that product here. So 3.26 multiplied by 0, pardon me, multiplied by 4.56, and that gives me a result here of 15.2. You could round it off to 15.21. I'm going to write 15.2098. I'm just going to keep it as that for now, divided by, say here, 0.9986. all right. And again, a lot of my students, they got to this point and for some reason lapse in concentration, they went ahead and they subtracted before they divided, which is breaking the rule, because then you'll see here that after m comes the d operation. So therefore we'd have to rewrite the 85.18 and take away the quotient of this result here. So therefore we have 15.2098 divided by 0.9986, and we should end up with an answer, say here, of 15.231. all right. And I'm not really rounding off, guys. I'm just writing a bunch of decimal places. As I said, the more decimal places you have is the more accurate your answer is going to be. So I'm thinking here 85.18, say here 85.18, pardon me, just a second here, guys. 85.18 take away, say here, 15.2311 gives me an answer here of 69.94, say here, 89. I like 4 decimal places because a lot of the times you're going to find that they're going to ask you follow-up questions. So I'm going to work with 69.9489 as my exact answer without any rounding off. all right, so that's what we have there. And so going forward, ladies and gentlemen, then that once we have completed, say here, the division and there's no addition involved, then of course lastly, once we subtract, we get the answer of 69.9489. Now it did, for this particular paper here, we did have some follow-up questions where we asked to round off or correct your answer to 1dp, to SF, and also standard form to 1 significant figures. Now I didn't have any student that got all 3 right. I had students that got 1 right, got 2 right, they got the first one and the last one right, they got the first and the second one right, but they didn't really connect with all, right? And I felt like some rounding off was an issue, so they didn't really get the accurate answer that I was looking for. But here's the approach to this particular question. Then we have this answer here of 69.9489, and the very first thing we were asked is to round it off to 1 dp. So again, for 1 decimal places, just as a quick little reminder here, guys, that decimal places is very self-explanatory there. We are focusing only on the digits that comes after the decimal point. So we're looking to bar off the number at the first decimal place, and you'll see here that 9 is the digit that holds the first decimal place. We're going to be drawing a vertical line here, and we're going to be checking the digit that comes after. Say here that it is 4. Now once the digit that comes after is less than 5, we're going to just simply ignore those digits and just rewrite what, say here, is left. So it is 69.9. That's for our answer. Now we did went ahead here and we were also asked to round off the very same number here, 69.9489, but this time we wanted it to 2 significant figures. And so what I find that a lot of students get confused when it comes to doing this whole significant figures is that they get it mixed up, where they completely forget that significant figures basically means digits that are greater than 0. Now you have to be a little careful because there's going to be examples where zeros are significant. Now if you want a tutorial on this, hit the like button, leave your thoughts and comments down below, and I'll make a complete tutorial guide. Or you can visit my other college YouTube channel where I went through this topic in its entirety. So for this particular number here, we're not going to be discussing the importance of 0 being significant, but we're going to simply focus on the fact that significant digits are digits that are greater than 0. So it is this case here where our focus is not necessarily after the point, but it can also be before the point. So what we're looking at here is the fact that 6 and 9 are our first two significant digit. Once again, we draw the bar line here and check the digit that comes after. Now in this example here, you're finding here that 9 is in fact greater than 5. So therefore then, we're going to be adding 1 to 69, and you're going to find here that we end up with an answer of 70. That is two significant figures. All right, and then this last part here, I find that a lot of my students did in fact made it quite chaotic. They did not get it right. I maybe think like 2, 3, maybe 5% of my class got this question right. Still, this is a problem for some students, and you really don't want to throw away easy 1 or 2 marks for this type of question. Now bear in mind that when it comes to rounding off or rewriting a number in standard form, what we're looking at here is in fact moving the point into a specific direction. Do we move the point this way, or say here, do we move the point say here that way? Where do we move the point is completely dependent on where our first non-zero digit is. So we are looking to move the point, say here, this direction. Why that direction? Because 6 is our first non-zero digit. Now by moving the point between the 6 and the 9, we then end up with a number that is then in fact greater than or equal to 1, but at the same time it is in fact less than 10. Do see the link in the description box or right here in the cards where you can get a full tutorial on the whole aspect of standard form. Say here, so this number becomes 6.99489 multiplied by the constant 10, because standard form is base 10, and we have to raise this to a particular power. Now the power that we raise it to is completely dependent on the amount of spaces we jumped. So in fact we jumped 1 place to our left, and this works opposite to the number line. So 1 place to our left make the power here positive 1. So we could just leave it as times 10, but I like to write the 1 there for accuracy, just so the student understands that there is always a power. Now they did in fact ask us not just to just round it off or write it in standard form. They did went ahead and say that we should actually make sure it is in one significant figure. So we have to make certain that this is rounded off then. So what we're looking at then is in fact rounding this off, say here, right here. So this here becomes 9 is greater than 5, so we're going to add a 1 to 69. I'm going to visualize this number as being 69. I'm going to end up with 7.0 multiplied by 10 to the power of, say here, 1. All right, so that would have been our answer there to 1 decimal place. All right, one significant figure, that is. All right, so I really had to spend a little bit of time on that. It's a very simple question to work out, but when you find that a lot of students are taking this question for granted, you'll find that these 3 marks could be the difference between passing and failing. You will never tell. So you definitely want to zone in and capture all these little tiny marks that you actually may have missed out on. So that would have given you there a maximum of, say here, 6 points. All right, so beautiful, we are off to a fine start. Let's then move on to the next question, and what we're looking at here is a worded problem involving percentages. And so here we're looking at the fact that a sales company is offering 12.75% discount on all shirts bought in the store this week, and 9.2% on all blouses bought in the store for this week. Now, if a customer spends $4,400 on shirts and $2,700 on blouse, how much did the customer, does the customer actually spend? This would imply how much does the customer spend after it was discounted. Now, I did give my students a little bit to think about, because I dropped in the whole mixed fraction percentages. I could have easily given them 12%, 9%, 8%, making it quite simple. But I had to add in that little fraction because we went through the topic of how to deal with the questions where you have mixed fractions. So this is a perfect opportunity for me to show you a quick little shortcut when it comes to this particular question. So what you're looking at here is in fact that a customer then say here spends $4,400 on say here was it shirts? I believe it was shirts. Let me just double check. Say here we spent on shirts, right? So it's shirts and blouses. So $4,400 was spent on shirts and a discount of 12.75%. Now everyone on this channel will know that when it comes to percentages, the simple process is that a percentage is a fraction whose denominator is 100. So what we're looking at here is in fact 12.75%. Now here's a shortcut. As opposed to after converting this mixed fraction, because we've said this already, doesn't matter what you're doing, once you see a mixed fraction, the idea is to convert the mixed fraction to an improper. So what we want to do here is in fact say here 4 times 12 is in fact 48 plus 3 is in fact 51 over, let's take a pause. Here's the shortcut. We could simply say here 51 over 4 all over 100 and do some fancy math, but here's a simple shortcut. Once you have a mixed fraction percentage, as opposed to dividing it by 100, you're then going to simply divide it by 4 or divide it by the denominator times 100. So as opposed to saying 51 over 100, 51 over 4 over 100, we simply say 51 over 400. I hope you guys caught that. Then we're simply going to multiply then say here by 4,400. So that's 51 over, as opposed to 100, we go 400 multiplied by 4,400. And even though I made it a little difficult with the percentage part, I also made it quite doable where the students didn't really have to use a calculator for the cancellation. 400 then into itself one time, and 400 into 4,400 goes say here 11 times. So we end up with an answer of $561 here for the discount. Now moving on then again to 9 2/3%. What we're looking at then is in fact say here 3 9s is 27, and 27 plus 2 is 29. Take a pause. As opposed to putting it over 100, we're going to be putting it over 3 times 100. I hope you guys caught that little shortcut there. And again, I've made it quite simple with the numbers. Say here I've given them a challenging part to remember, but an easy cancellation. 300 into itself one time, 300 into 2,700 goes in fact say here 9 times, and easily then 9 multiplied by 29 is in fact $261. All right, so how do we know how much a customer spent? If you want, you could actually subtract the 561 from the 4,400 and subtract the 261 from the 2,700. But I'm simply I could do that, or I could simply add up the 4,400 plus the say here 2,700, and I'm going to subtract that result then from say here, I'm going to subtract that result from say here 561 plus say here 261. So 4,400, that's going to give me mathematically, that works out to be 7,100. Let's double check on that. That is correct. And then this gives me say here 561. I think I took a different approach, but okay. This is going to be 761. Let's double check that on our calculator, guys. I took a different approach to the problem because I'm looking at my answer sheet at the moment, but I'm taking a different approach. See here. Okay, so this is 822. And so therefore then our final answer is 7,100 minus 822. That gives us an answer of $6,278 for how much the customer would have spent. All right, so that is how you approach the question. So as much as how it came across a little bit challenging to a couple of you guys, I did in fact make the cancellation easy, but the conversion and remembering, as opposed to dividing by 100, we then divided by the denominator times 100. All right, so hopefully you guys catch on to that, and in the event you can go forward and get more problems correct when it looks like that. All right, beautiful. Let's then move on to the next question then. So what we're looking at then is in fact to solve or find the value of 15 plus 13 squared divided by 15 squared minus 13 squared. And a lot of students actually got this question right, because it's a very simple question when it comes to working this out, because it's just a very basic question where you're looking at using the law of PEMDAS. So you're simply going to be working out the top part, work out the bottom part, and divide both answers. So I find that a lot of my students were very successful in acquiring these 2 marks, but I do have a surprise for you. There is in fact a very cute and cheeky way to work out this problem, because this problem comes with an advanced principle known as the difference of 2 squares. A lot of my students are not familiar with what that is called, so I didn't really expect them to approach the question like that. But let's work out it the traditional way here. 15 plus 13 is in fact going to be, say here, 28 squared. All right, and then at the bottom then we're looking at 15 squared is 225 and 13 squared is 169. So if you jump on our calculator here and we square, say here 28, so if we square 28 we end up with 784, and that will be divided by 225, take away 169, and you're going to find out this is 56. So easily then my students would have gotten an answer here of, say here, 14. All right, so that was pretty easy question, easy 2 marks. But here's a cheeky way of working this out. Say here 15 plus 13 squared. What is, and let me put this in a different color ink. Cheeky little way here. 15 plus 13 squared is in fact 15 plus 13 multiplied by 15 plus 13. Right? Because when you square a quantity, whether it be a binomial or an arithmetic problem, what you're doing is that you're asking to multiply what is in the bracket by itself. Then say here divided by, this is the cheeky part, and if you're an advanced student you'll recognize that this is actually a difference between 2 perfectly squared values. Now when you have a difference of 2 squares, then what you're going to be doing is that you're going to be having one bracket being plus and one bracket being minus. So you end up with 15 plus 13 multiplied by 15 minus 13. Advanced concepts coming up. Do subscribe to the channel to look out for that topic when I post it then. So what you're going to be looking at easily here is in fact cancelling out, say here this with this, and so you end up with here, say 15 plus 13 is in fact 28, and 15 minus 13 is in fact 2, and easily and very cheekily we get an answer of 14. All right, so I know that quite a bit of my students be like, I'm not sure what I did. But as soon as you learn the concept of the difference of 2 squares and you start to get an eye for that type of expression, you're going to find that this is the most easiest way to approach the question. All right, so hopefully you guys latched on to that. A lot of you guys did in fact get that right, but let's then move on to the next question then. And so again, this particular topic, I keep bringing it back on my tri-weekly exams and monthly exams, because I find that the math is not really the problem. I did find a lot of students, a good amount of students, this time it's on the 40-60 line, where 40%, maybe 30% of the students got this question right and 70% got it incorrect. They got it incorrect simply because they didn't read the question properly. And in all my tri-weekly exams and monthly exams, I find that a lot of my students keep forgetting that there are always going to be a change in the relationship between the variables. Now, this topic is not a major topic on the curriculum of c.x.c. It pops up now and again, and when it does, it doesn't come as challenging as how I usually give my students on my exams, but you just don't want a question to be a curveball question. You want to be prepared for whatever question hits you in an exam. Alright, so with this particular question here, again, a lot of my students complained about the table format of the question. Let's jump right into it here. Now, I did have to make a change in the formation here. I had to bring up a couple of values. I made a typing error. This should have actually been 960. This should have been 2080. This should have been 2600. And then this should have been 4. And this should have been 11. So I'm going to cross this out here, cross this out here, and cross this out here. All right, so those were the total earnings, typing error, and these were the number of passengers. Now, here's where my students often fall off. And if you're watching this video in the future, when you get questions like this, whether on your end of term exams or on your future exams, always read the question to see if there's a change. And here we're reading that the amount of money that a taxi driver makes on a given day is directly proportional. This is the part that caught my students. The cube of the number of passengers. They immediately recognize that there is a direct relationship between, all right, and I did also find a couple of complaints coming in that they thought that it's a direct proportional question. Remember that the word proportion and the word varies are used interchangeably. I had to throw you off a little bit, guys, with that question. So when you see directly proportional, it also means directly varies as. All right, so traditionally then the usual formula is in fact y is equal to k multiplied by x. Let me just use a dot here. So it's k multiplied by x. So then you're going to find here that there's a change in the variable, because now it says that the amount of money that a taxi driver makes, the amount of money, that's going to be your y, that's the total earnings. So y is directly proportional to the cube of the number of passengers. So whatever represents passengers, which is x, is going to be cubed. And a lot of you guys would have not gotten any marks simply because of this one tiny error. This one tiny error here, where you forgot to cube the x, throws off a whole lot of problems, all right, in your solutions. So let's go to our blank slate here. On our blank slate here, you'll see the corrections being made, and so our formula that we're working with here is in fact y is equal to k multiplied by x cubed. And as advised time and time and time again, that in order for you to evaluate a variation problem, you need to obtain the value of the constant of proportion, or the constant of variation. Now, a few of my students, I don't think I may have necessarily taught them directly how to approach the table questions, so they did find that challenge. But I also advised you guys that you have to observe the table and see which of the columns in the table gives you two initial values as a start. This particular column here, it gave you the value of y, but it didn't give you the value of x. This particular part here, it gave you the value of x, but it didn't give you the value of y. And over here it gave you the value of y, but it didn't give you the value of x. So it is this part of the table here that you're going to be using as a starting point. Now you'll notice here that y is in fact 2080, and then k obviously is unknown, and then x cubed here becomes 4 cubes. So this 2080 here is equal to k multiplied by 4 cubes. Is not 12, but it is in fact 64. So if we can divide both sides here by 64, you'll find here that your constant of proportion works out to be 32.5. 32.5. 32.5. And so once we have that beautiful constant of proportion, that will then able to propel us to working out the remaining sections of the table. So we go ahead and we process by rewriting our formula, and then now we look at the other part of the table. Now in this first column of the table, you were given the value that is in the y row. So that means y is 960. That goes underneath y. K obviously worked out to be 32.5. And then we're looking for the amount of passengers, then say here. All right. So then what we're looking at here is in fact the number of passengers. So we have to obviously divide both sides by 32.5 because that is how we isolate x cube. So 960 divided by 32.5, that gives us x cube. So then let's jump on our calculators. That is the calculator. That's 960 divided by 32.5. That gives us an answer then say here of 29.53 equals x cube. So therefore easily then to find x, we're going to cube root the left side. So that's 29.53. So when you work this out, then you're going to find here 29.53. So that's, I think that the answer that I got, my calculator doesn't have a cube root on it. But when I did the calculation earlier, I got a rounded answer of 3.0 something. If you go on your calculator, you can verify. But since we're talking about the number of passengers, we want to give it a whole value. So it's going to be approximately, say here, equal to 3 passengers. All right, once again, let's bar this off. Rewrite our formula. Y is equal to k multiplied by x cube, and then bar this off again. So let's get into it then. We're looking for this column here where we're given the number of passenger, which is in fact say here x. So now we're given x to be 11 and we are looking for y. So y is equal to 32.5 multiplied by 11 cube. So when we do the math here, y is equal to 32.5 multiplied by 1331. And when of course we work that out, you're going to find here that the amount of money made by this taxi driver is in fact 43,257.50. And this number kind of spooked a few of my students because they were pretty concerned as it relates to, can an actual answer be this big? Remember that the question is built as a realistic question, so as long as you apply your formula, then you should be in fact okay. And so finally then, which you don't usually get so many columns on c.x.c to fill out, it's usually 2 or 3 columns, but I felt like I wanted to just kind of test my students' ability to repeat what they have done. So again, I gave them another column here, y is equal to k multiplied by say here x cube, and if you look on the table here, you'll realize that x again is missing. So the same procedure that they used in column 2 here, they're gonna have to do that again. So again here, you're gonna recognize here that say here y is unknown, pardon me, 2600 is y, so that's 2600, and that's equal to 32.5 multiplied by x cube. Again, dividing both sides by 32.5, that's x cube. So you're going to find that x cube then is equal to, okay, just a second here guys. So when we divide that, I got exactly 80. So x cube is equal to 80 when I divided it. And so x then is equal to the cube root of 80. Remember that we use the opposite root or the corresponding root to remove the power. And when we work this out, we get an approximate answer of say here 4. Well, we got an answer of 4.3, but we know we can't have 4.3 passengers, so we simply can say that the answer is approximately equal to 4. All right, and that is how you literally collect that 8 marks on that particular problem. Once again, ladies and gentlemen, boys and girls, if you're watching this for the first time, you are obviously getting the ultimate tutorial when it comes to mastering your tri-weekly, monthly, and preparation extensively for your exams. All right, so please share this video out if it's of benefit to you, and of course do not forget to hit the subscribe button. I do post content on a weekly basis, live classes. Coming up in December, there's going to be a lot of review on the channel as it relates to topics that were taught for this year, and of course great things are coming in 2024. So become a part of the first 1,000 members of this particular channel. Let's move right along then to say here the next question up top. And so the next question was just that little touch, just giving that student that little cushion, giving them that little bit of confidence to know that they're not going to get a 0%. So this question was a really nice, easy one, nice one. A parent is doing back to school shopping for her child and saw that an 8-book packet cost $1,280.50. She wanted to purchase 13 similar books. How much should she have paid, or should she pay for the 13 books? And this is a very simple problem, believe it or not. And a lot of you guys may be thinking that I'm saying it simple because I'm a math teacher. It is actually very simple, and simple in the sense that all you had to do was simply write down the fact that 8 books cost $1,280.50. all you had to do was just find the cost of one book. So one book would have been the equivalent of 1280.50 divided then by, say here, 8. So if we hop on our calculator then and we divide that by 8, you'll find that one book would have cost this parent, say here, $160.06. So she wanted 13 similar books. So 13 multiplied by 160.06, and mathematically this worked out to be $2,080.81. That's just one way of approaching the problem, right then? Beautiful. So that's going to be our answer there. A lot of students got that right. All right, so now we're going to be moving on to a very interesting ratio question. And I made some errors in my answer sheet, which my students highlighted to me. So a lot of my students gained a bit of extra marks, which pushed quite a few of them over the pass mark for this exam, which was about 55%. All right, so I do apologize for giving you answers that were incorrect. If you're watching this video and you have access to the paper, or you have done your calculations already and you recognize that you're missing some marks, do feel free to come to me and attain your full correction. All right, I do apologize for that then. Let's just quickly erase this from the screen because we're going to need some space for this question. And so as we get into it, what we're looking at then, and let's just give it a good read. We're looking at the fact that 3 students were given a sum of money to be shared amongst themselves. And these 3 students are in fact Alex, Andre, and DeAndre. 3 students that are currently my students in the 2023-2024 exam. Now, the ratio in which they were given to share the money was 3 to 7 to 5. Now, we are told that Andre received $3,500 more than the amount that DeAndre received. Using this information, we are to find the total sum of money that was shared. Now, I've already been through this on one of my previous tutorials. Again, check the link in the description box below to my playlist on fundamental math. Of course, the video on ratio was most recently posted, so do check out that tutorial. I went in deep details of how to approach questions like this. Once again, I'm going to use my traditional 3-step process to solve my ratio problem. I'm going to first write down the comparative quantities. In this case here, I'm looking at the fact that Alex compared to Andre compared to DeAndre were the persons in the ratio. DeAndre, and the ratio was in fact 3 to 5 to to 7. A lot of my students didn't even write down that part. And why I like taking this approach, it just gives me a sense, it gives me, and I think it should give my students a sense of comfort to knowing that one step leads to the next. Of course, the second step would have been obviously to find the total proportion. We don't necessarily always need to find the total proportion, but we never know when you're going to ask us to find the total sum of money that was shared. So this is going to come in handy. So to find the total proportion, obviously we're going to be adding the 3 plus the 5 plus the 7, and so that works out nicely to be, say here, 15 shares. In a moment we'll come back to that. We're not sure if we're going to need it, so let's just put it in red here and hold on to that information. We're going to move on then next to finding the total, or finding one share. Now there was a little twist in the question, because of course when we read the question earlier, I find that a lot of students mentioned the fact that, well, at least they thought that Andre got 3,005. If we read on further, we'll see that Andre actually got 3,005 more than what DeAndre got. So then this kind of minimizes the ratio that we're looking at. Then we're looking at, in fact, the ratio between, say here, Andre. So let's grab a different color ink here. Let's compare, say here, this section of the problem to this section of the problem here. All right, and that's our focus is on. So why is it that Andre received, is it supposed to be more than or less than? I think I may have made a typing error here. Hold on guys, let me just double check on this. It says here that Andre received $3,000 more. This actually should have been less. Is it possible that I may have thrown off my students? I'm not so sure. I think that was a typing error. I'm not sure if I had made the correction in the class, but I apologize for that, guys. Andre received $3,500 less than what DeAndre received. Or, if I remember correctly, I think my thought process was that I wanted Andre to receive more than Alex. I think the question was supposed to be not DeAndre, but Alex. But nevertheless, alright, nevertheless, we're going to be working the question as it is. Let's just make this one change here. As opposed to being more than DeAndre, let's do less than DeAndre. I actually wanted this to be Alex, but nevertheless, let's work the math. So, Andre received $3,500 less than DeAndre. The question is, why? Or, by how much? By how much did Andre receive less than DeAndre? When you look at the numbers, you'll see that the reason why DeAndre received less than DeAndre is simply because DeAndre had 2 extra shares. So we can safely go ahead then by saying here then that the difference, pardon me, so we can safely say here then that the difference in shares is equal to 7 take away 5, which is in fact 2 shares. So that 2 extra shares that we have calculated here is the exact reason why Andre would have received less than DeAndre. So 2 shares is what's equal to the 3,500. If we divide both sides by, then say here 2, we'd have attained the value of 1 share. So 3,500 divided by 2, and that actually gives us, say here, 3,500 divided by 2, that gives us 1,750. And we have completed all 3 steps of our ratio problem, right? And this is what I encourage my students to do. Do this type of approach. It gives the c.x.c marker a very good idea that you know what you're doing. You've got to try to accumulate marks for understanding and for knowledge. Even if you were to make a fundamental arithmetic error, it will show the examiner that you know exactly what you are doing. So now that we have the value of 1 share, let's proceed then to looking at what is it that they have asked us to calculate here. So they have definitely asked us here to calculate the total sum of money that was shared. And as I had predicted, most likely they are going to ask that question more often than not. So of course what we're looking at here then is in fact that 15 shares is the total and one is valued at 1750. Therefore total sum is equal to 1750 multiplied by 15. So we end up with a total here of $26,250. That was the amount that was shared between the three students or the three friends. All right, so that approach to that particular question. Then let's move on to see here part 2. So in part 2 I added a little bit of twists, and like I said, whenever I'm writing these questions I need my students to think outside the box. I need my students to be able to read with understanding. It's not always going to be obvious. I'm actually preparing my students for more than what c.x.c usually sends towards the plate, so that when the time comes they'll have enough experience within the course of 9 months to attack any problem. So by adding this little twist, as opposed to asking my students to express Alex's share as a percentage of the total or Andre's share as a percentage of the total, I added this word here, and for those of my students who would have heard me say that the word and in math means to add. So in this case here, if you're going to be expressing Alex and Andre's share as a percentage of the total, we need to add Alex's amount and Andre's amount together. You can do it from the amount perspective by calculating the amount of money that Alex received. We already know how much money Andre received. Well, we have to calculate that as well. I feel like to approach this question, it is best to approach it from the shares perspective. So we know that from earlier that Alex is the one that got 3 shares and Andre is the one that got 7 shares. So therefore I know that together Alex and Andre would have had a total of, say here, 10 shares. So we know that there's a total of 15 shares. So easily then, to get this particular question correct, we can easily say that 10 plus 15, 10 divided by the total of 15. This 10 represents Alex's and Andre's share together. So that's 10 out of the 15 multiplied by 100 as a percentage. Therefore, you're going to find that the answer is 67% rounded off. That is 66.66666 rounded off to approximately 67%. So together they would have acquired 67% of the money. All right, and that is how you'd approach that particular question. Now, as usual, I oftentimes try to give my students a little bit more than what they would have asked for. Now, you definitely want to catch this type of question. I haven't really seen, or have I ever seen, this type of structure. I may have seen this in a textbook probably a couple of years ago, but this type of question here where it says that if Andre gave Alex $750 from his amount and DeAndre got $500 from Andre, well, pardon me, let's read that again. If Andre gave Alex $750 from his amount and he also gave DeAndre $500, what is the new ratio? None of my students actually even approach this question. I know that you guys are probably saying that I didn't teach you, but I was expecting a little bit of thinking throughout this question. So here's how you're going to approach this here. First, let's write down the amount of money that Andre has in bank at the moment. So Andre, let's check that out. So Andre would have had a total at the moment of 5 multiplied by 1750. So let's go to the calculation here. 5 multiplied by 1750. Pardon me. 5 multiplied by 1750. So at the moment here, Andre has in bank 8,750. Now, according to the question, Andre gave Alex 750 from his money. So after giving away 750, Andre's amount now is equal to 8,750 take away 750, which leaves Andre with $8,000 at the moment. That is after giving Alex $750 from his amount. As it says here, Andre gave Alex 750, but he also gave away another 500 from his amount. So therefore then another $500 is subtracted, right? So that means Andre then would have gotten Andre's amount now. So this is first attempt. Second time now, Andre's amount is now going to be 8,000 minus 500. So Andre's final amount that he has now is $7,500 in bank. Let's just rewrite this question to give ourselves some space down here. Alright, so now this is what Andre currently has. But remember now that Andre gave Alex 750, so Alex's money would have also increased. So Alex's amount now is going to be 750 plus what he already had. So Andre, we know, would have had 3 shares, 3 times 750. So Andre would have had Alex would have already had 3 multiplied by 1750, plus we added $750 to his bank. So basically then Alex now has $6,000. Okay, so Alex's share would have been his initial, so that's minus 750. So Alex's original share would have been 5,250 plus Andre just gave him 750, so he now has $6,000. And remember also that Andre gave $500 to DeAndre, so DeAndre's amount, and I understand guys that this probably is a tricky little question, but this is what it requires to get a distinction in math. You have to think outside the box. DeAndre's amount at the moment would have been, say here, she got let me see here, she got, let's go back to the question. She got 5 shares, right? She got 5 shares, so it would have been 5 multiplied by 750. So that's 5 multiplied by 750. So she would have had initially 3,750. Oh, pardon me. That is 5 multiplied by 1750, pardon me. She would have already had, before getting the 500, she would have actually have 8,750, and she got $500 from Andre. So she now has 9,250. Alright, good. So let's circle these values then. So Andre, after giving away some money, has 7,500. Alex received an additional 750 on his amount. He has 6,000. DeAndre received $500 on her amount. She has 9,250. So in order for us to calculate the new ratio here, we're going to have to lay them out. So Alex would have now had 6,000 compared to Andre, which now has 7,500 compared to then 9,250. And if we can reduce these fractions as fast as we can, I'm thinking maybe we could use 250. So let's see, 6,000 divided by 250. That gives me an answer here of 24. 7,500 divided by 250. That gives me 30. Already telling me that this can be reduced further. And this is now 9,250 divided by 250. That gives me 37. Alright, and that would be my new ratio, because now the ratio cannot go any further. The new ratio after Andre gave away some of his money has now shifted from being 3 to 5 to 7 to now being 24 to 30 to 37. All right, so look out for that question on your end of term exam, guys. You're gonna get one similar to that. I'm giving you a heads up from now. That is how you approach that particular ratio problem. All right, so I know it was a tricky one, a challenging one, but now you have experience with how to approach that type of question then. All right, now we are just about an hour over into the exam. Let us just continue and get a full complete review on this exam then. See here. So we're going to be moving on next then to the algebra aspect of the paper. And so again, my students had improved in this area. In quiz number 2, they made a whole entire mess. They confused the rules of adding and subtracting with that of multiplying and dividing. This time they made a drastic improvement after the correction. So that is how I know that these tutorials are actually working. Because for the students who actually watch these tutorials, they find that this particular type of question here really is far simpler than they thought it was. So here we're just asked to group. As again, I still have a few students messing around with the powers when we're adding and subtracting. Here we're just simply asked to group here. So 4p, looking for any other term that has a p, that's minus 5p. Then we're going to be grouping the q squares, so that's minus 2q square. And then we're looking for any other q square, so that's plus 2q square. Then now we're looking for all the 5p squares, all the p squares, pardon me, so that's 5p square minus 6p squares. Now everything is now in order. It is time to subtract. So 4 take away 5, that is equal to negative 1, which we don't usually write 1 in algebra. We simply just write the variable, so that's minus p. Notice then here that these are additive inverse. So negative 2 plus 2, same number, different signs, cancel out, and then simply then we end up with a final result here of 5p squared minus 6p squared. That's 5 minus 6, that is negative 1 again. We don't usually write the 1, so we write p squared. So our answer then therefore is in fact minus p minus p squared. All right, maybe the response, maybe the result would have spooked a few of my students. They may have made at the error that I saw most often in this question was that the fact that they kept writing negative 4 as the answer. Some students recognized that it was a cancellation, while a majority of the students understood that the actual problem was cancelled. So our answer then therefore is minus p squared. Again, what I find in this particular question then was that a lot of students recognized that they needed to add the powers and subtract the powers. But what they did is that they actually mentally tried to work out the problem. Now, if you're an advanced student, perhaps like at the college level, then you're going to find that you don't necessarily need to take the approach that I'm about to show you. You can mentally do it if you know you're comfortable with your integers. But if you know that you often make that odd sign mistake I do, and I strongly recommend students that if you want to get these full 2 and 3 marks question, please write down your integers. It doesn't take more than a couple seconds to write it down. Write it down so that you guys do not lose half mark, 1 mark, 2 mark by a very basic process of adding integers. So here I recommend that the students go ahead then and they'll say group the numbers. 8 divided by, say here, 2 multiplied by, say here, 3. And of course group all the x's together, so that's x squared. We're going to be dividing that by the next x, which is x to the minus 4, which we're going to be multiplying that then by the next x, which therefore becomes x to the power of 1. A lot of students missed that part there where they didn't see the power. They made the assumption that the minus 1 that is here is for the x and for the y. When there is no power that is above a variable, please bear in mind that the power understood is a 1. Grouping all the y's together, then we have y raised to the minus 3 divided by y raised to the minus 5 multiplied then by y raised to the minus 1. And whilst as a teacher, if I'm doing this for myself, let's say that I got a problem like this in college, I don't necessarily do this. I will skip a few steps because I'm an advanced, obviously I'm an instructor. But for a student who definitely just wants to take your time and go through the problem, you definitely want to do something like this. Then say here, so we have 8 divided by 2 is in fact 4, and 4 multiplied by 3 is in fact 12. Then we just rewrite the base of the x, and then we're going to, here's where my students fell short. They kept trying to do it in their minds mentally, and they're not strong enough as yet. So what I recommend that you do is to write it down. Say here 2, you're dividing, so you're going to subtract -4. Nothing is wrong in doing this, guys. And then you're multiplying, so you're going to be adding 1. Nothing is wrong in you writing down your stuff like that. Y, that's -3. I am dividing by the second y, so that's take away -5. And then of course I'm going to be adding, say here, -1. Say here, right there. Alright, and then at this stage there is absolutely no excuse. If you've gotten this far, you shouldn't get the question incorrect. Surprisingly, I did find a lot of students that got down to this part and still wrote down the incorrect answer. Alright, if you're one of those students, I strongly recommend that you just simply type into your calculator what you've written down and verify. For me here, I do not have a calculator, so I'm going to have to do it manually. Say here, negative times negative. Let's zoom up here. Negative times negative is positive. So this becomes 2 plus 4 is 6. 6 plus 1 is in fact 7. And then here say y. Here what we have now is you owe 3. Negative times negative is a positive. So if I owe 3 and I have 5, I'll pay the 3 that I owe, and I will still have 2 left. Now that I have 2 and now I owe another 1, once I pay what I owe, I'm going to have 1 left. You don't have to write the 1, but I like to write the 1 here for teaching purposes. So therefore then my final result here is in fact 12x to the power of 7, y raised to the power of 1. Alright, and that is absolutely how you blast through that question. Alright, now we're going to be moving on then. I think at the time of giving this particular problem, my students may have just gotten the weekend to review this. You can check out video tutorials on my channel. Recently posted about a few days, maybe 4 or 5 days ago. You would have seen where I did a complete tutorial, part 1 and part 2 of binomial expansion. I did a video on distributive law and I did a video on binomial expansion. So check that video out if you want to get a very good idea of what I'm about to do now. So what we have here is 3a take away 4 open bracket b minus 2 close bracket open bracket 5 minus 2b. How do you approach this question? Well, I've advised my students in my previous tutorial video, which I'll link is in the description and right here in the cards. I would particularly approach the binomial expansion first. I would therefore write down my 3a take away 4 and I will open a huge square bracket here, and then what I'm going to do is that I'm going to then distribute the double brackets. That's the best approach. So you want to go ahead and say here distribute the b with the 5 and the b with the minus 2b, distribute then the minus 2 with the 5, then the minus 2 with the 2 minus 2b. And of course remember that distribution means to multiply. Alright, once you approach the question like this, then the next thing that you're going to be doing is just a simple distribution. Okay, basic distribution. Again, just be reminded that you cannot subtract unlike terms. So in the event that maybe this was a 10, say for example this was a 10, I don't expect any of my students to say 10a take away 4 is in fact 6. That's going to be a brutal error, and that usually gets me all riled up. So I definitely don't want to have to punish my students for mistakes like that. Alright, so just be aware that if the terms are unlike, you are not allowed to subtract or add them. Here we go. We're going to go b times 5. That is going to be, say here, 5b. And b times minus 2b. That is minus 2b squared. Okay. Then next we're going to be distributing the minus 2 with the 5, so that's minus 2 times 5, that's minus 10. And minus times minus is a plus. We end up with 2 times 2b is 4b. Alright, then we're going to close that square bracket then. And then finally now, all we're going to be doing here is just distributing the minus 4 here, 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 and here. Alright, so we're going to be distributing that. What we're looking at then is, in fact, say here 3a, pardon me, so what we have then is in fact 3a, take away, let's distribute, negative 4 times 5b, that is negative 20b. I could simplify here if I wanted to by adding the 5b to the 4b, but I think I just want to keep it simple, just distribute, just do one thing at a time. So negative times negative, remember that the sign outside affects the sign inside. 4 times 2, that is 8b squared. Negative times negative is positive. 4 times 10 is 40. And negative times positive is negative. Remember, the signs will be affected. 4 times 4b is 16b. And so therefore now easily we can group like terms. We have 3a. Check to see if there's any more a's around. There is no more a's. Let's do b's. So that's minus 20b. Are there any more b's? Yes, that's minus 16b. And say here no b squared, so that's plus 8b squared. And then finally then we have plus 40. Alright, and so easily then the only terms that are alike here is the ones that are in the middle. So we end up with an answer of 3a, that is going to be minus, say here, 36b. Let's make certain that we have it right. Negative times negative, positive, positive, negative. Okay, so that's minus 36b plus 8b squared plus 40. All right, let me check my answer sheet to see if I may have made an error. I'm feeling like I made an error somewhere on my answer sheet. No, I've got it right. I've got it right. So it is in fact 3a minus 36b plus 8b squared plus 40. And believe it or not, I have only one student that actually got this question right. Her name is Monique. Well done on that particular question, dear Monique. All right. Good, good, good. So that was a itchy type of algebra, right? Definitely look out for those types of questions in your next monthly exam and also in your end of term coming up. All right, let's move on then next to the other question, which is in fact going to be, I believe, the graphical. Now, at the time of the construction of this exam or the design of this exam, we had just barely got into coordinate geometry. The only thing that we had done was up to gradient graphically. So that's just that part that you're going to be seeing. But on the upcoming videos, you're going to be seeing deeper questions on gradient of lines, length of line, midpoints of line. If you want to go ahead of the class, you can check my very detailed 3-part series that I have on coordinate geometry. You're going to find part 1, part 2, part 3. I'll try to leave a link in the description box below, or you can just click on videos on my channel, scroll down to the bottom, you should see the title coordinate geometry. I went through coordinate geometry in details. When I say in details, I left out nothing. If you watch those 3 tutorial videos, there is absolutely no question that c.x.c can bring to you that you'll not be able to answer our master. All right, so let's get into it. Here it says that given the following points, a minus 2, 4, b 5, 1, and c 0, minus 5, we are to plot the following points and draw the lines AB and BC. So let's get it. It says minus 2, 4, 5, 1, 0, minus 5. gonna have to skip back to that. My brain's a bit shallow. Minus 2, 4. So I have a graph here that's already designed, right? And if you know anything about coordinate geometry, you'll know that this here is our origin right here. And so each of these numbers here, which I'm not going to be labeling, are going to be 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, up 1, 2, 3, 4, down 1, 2, 3, 4, and so on. All right, my graph is a little small, so I really don't want to make it untidy. So just know that each of these lines going across represents 1 unit. All right, so the first one was minus 2, 4, so that's minus 1, minus 2, and we're gonna go up 4, so that's minus 1, minus 2, 1, 2, 3, 4, so that is right here. All right, so that's going to be our point A. And then of course we're going to be looking at, say here, let's see what we have. We in fact have the point 5, 1 and 0 minus 5. So 5, 1. So that's 5, 1. That's 1, 2, 3, 4, 5, and up 1. That's right here. And we have 0 minus 5. So that's B. And we have 0 minus 5. So 0 is in the center. We'd neither go left or right, and 5 down. 1, 2, 3, 4, 5. That's down here. And I don't have, I think my graph is so small, I'm gonna have to use my freehand. But if you guys have your ruler, you definitely want to just line these 2 points up. Say here, draw the line. And then of course you want to draw the line from this direction as well. So we were asked to draw 2 different lines, lines AB and line BC. And believe it or not, I gave my students 3 marks for this. 1 mark to draw each of the lines, 1 mark to label the axes properly, and 1 mark to plot the points, 1 mark to draw the lines, and 1 mark to plot the axes properly. A lot of my students made a horrible mess of how to plot the points. Nevertheless, as I said, the video tutorial is to give you a full advantage on how to do these things going forward. Alright, so then we were asked, what were we asked to do with this information? We were then asked to determine the gradient of the lines using 1, the graphical method, and we should also use the formula. So students had an option. They could choose to find the gradient of BC using the formula. But we could have found the gradient of AB using the formula, and then use the graphical method rise over run for BC. You had options. Alright. So since as it is that it's my free choice here, I'm going to use the formula for AB. So I'm going to be using the formula M is equal to Y2 minus Y1 over X2 minus X1. And remember that my points of focus are going to be minus 2 and 4. And of course B is in fact 5, 1. So just remember that those are my points. I'm going to then label my points. Right? If I'm using the formula, I want to call this X1, that Y1, this X2, that Y2. So I'll then go ahead and label my points. M is equal to Y2 is 1. Take away Y1 is in fact 4. Divided by X2 then is in fact 5. And X1 is X1 say here is minus 2. So then I end up with an answer here of 1 take away 4 is minus 3. And negative times negative is positive. 5 plus 2 is in fact 7. So from the formula, I got a gradient of minus 3 over 7 for the line AB. Now the instruction did specifically state that you should use the gradient formula for one and the graphical method for the other. So for the graphical method, I'm going to be using the formula M is equal to rise divided by run. I had to test my students' remembrance. I showed them both methods, but here we go. So from B to C, I'm going to create a rise in this direction, and I'm going to run towards my C. So I know that the amount of units coming down from B is in fact 1, 2, 3, 4, 5, 6, and I'm heading downwards, so that's minus 6. And then from here now I'm going to be running towards C. That's going to be 1, 2, 3, 4, 5. So that's going to be running towards my left. That's -5. So therefore my rise is -6 and my run is -5. So I get a gradient of 6 over 5. Alright, and that there becomes my gradient of my line. So that was what was required to answer that question. There wasn't a lot, because as I said, up until the creation of that exam last week, Monday, which was November the 20th, there was no, we weren't in too deep when it comes to coordinate geometry. But coming up next, you will be seeing more in-depth question on coordinate geometry. And in the meantime, give yourself a fighting chance by watching the tutorial videos, part 1, 2, and 3 on the coordinate geometry, linked in the description box below. Alright, so we are approaching 1.5 hours in this video. Let us see if we can wrap up this question under an hour and a half. We are at question 7, and the diagram represents the shape of a flooring plan of a building which is made with 2 rectangles attached to each other. Alright, and so the diagram was drawn on the board for my students, which is what you're looking at on screen here. This is the diagram that was drawn for my students, and I think they only answered part 1. None of the students were able to approach the latter part of the questions. As I said, it may have been a little bit spooky at first, but I'm hoping that within the next 6 or 7 minutes I can show you guys that the question was way easier than you perceived it to be. Alright, than you perceived it to be. So what we're looking at here is in fact a flooring plan where 2 rectangles are attached to each other in a rather interesting manner. It's like one is on the edge of the other, right? So we're basically looking at the floor of a building from the top view looking down. I would pretty much call these like holes in the floor. Alright, so I'm just going to call them like holes in the floor. Let us see if they had given us any more information on the diagram. They didn't give us much, just they say 2 rectangles attached to each other, so that was all that was given. We were in fact asked to find a couple of things actually. We were asked to find the side mark X. We were to determine the perimeter of the floor. We were asked to find the area of the floor and find the area of the shaded portion. Alright, so the shaded portion, I don't think I had it here. Let me just shade that part. The shaded portion is in fact all of here. And that was the shaded portion. Alright, here we go. So we need to find the area of that. Let us focus first on finding X, which is marked right here. This broken line that you see right here. Alright, and this was really easy. I find that a couple students did get it correct, which I congratulate you all. But I find that some students weren't able to even wrap their minds around the fact that this side at the top is 8.4 and a part of that line already we know is 2.6. So easily X is equal to, say here, 8.6 minus, 8.4 minus 2.6. And so therefore X equals to 5.8. And a lot of my students, that flew right over their heads. Alright, so you definitely just want to kind of tune in on that, guys. Alright, so we were also asked to find next, let me just make sure that I confirm this. We were asked to find the perimeter of the floor. So what we're looking at then is in fact the whole entire distance around the floor. That is this side plus this side plus this side, that side, this side, up, across, up again. Alright, so we have a few lengths here, and you have to be careful because I did find a couple students, not a lot, but a couple students throwing in that 5.8 there. That is not on the edge of the diagram, it is on the inside of the diagram, so that has nothing to do with the perimeter. Now bear in mind that it's a rectangle. They did say that it's a rectangle, so understanding the properties of a rectangle, that the opposite sides are equal, so we already know that this side here is 5.3, so this side over here is obviously going to be 5.3 as well. And if we notice here that all the way down here is 12.5, and we just calculated a part of it to be 5.8, so 12.5 minus 5.8, let's see here, is in fact 6.7. So that's 6.7 centimeter. All right. Let me make sure that I have that right. That's correct. Good. And then this side here is 6.7, 12.5. Remember that over here is 6.7 as well. So that's 6.7 as well here. All right. All right. So beautiful. That's what we have then. All right. Let me just make sure that I have all my answers correct. That's 8.4, 5.3 times 2, 12.5 minus 5.8. 6.7. Okay, I think I've got it right. All right, good. So what do we have then? The perimeter is going to be equal to adding up all of those measurements. So I did find a nice way to kind of quickly run through this, recognizing here then that there were in fact two 5.3. So as opposed to saying 5.3 plus 5.3, I did say 5.3 times 2 in a bracket, plus I did recognize that there were also three 6.7s. So I could say 6.7 as opposed to saying 6.7 plus 6.7 plus 6.7. I simply say 6.7 times 3. All right. Let me make that clear. So 6.7. Right, I think I've had it right. So as opposed to saying 6.7 plus 6.7 plus 6.7, so 6.7 times 3, throw in that 12.5 right down at the bottom here. Let's check. Then we have that 2.6 up top right there, and then we have that 8.4 at the top, so that's plus 8.4. I think I have everything right. So 5.3 multiplied by 2, that gives us 10.6. And then we have 6.7 times 3, that gives us 20.1. And then we have that 12.5 plus 2.6 plus 8.4. So we're gonna add 10.6 plus the 12.5 plus the 2.6 plus the 8.4, and we end up with a final perimeter here of 54.2 centimeter. All right, so yeah, that's what was required. So it's not really a difficult question. You just had to just use a little bit of intuitive thinking there. All right, then now we're asked to, once again, we're coming to the end of this video. We were asked to find the area of the floor. All right, the area of the floor includes everything. So the area of the floor is obviously going to be the area of the two rectangles put together. All right, because they're both, now, as it said in the question here, if we read it again, it says that the diagram below represents the shape of a flooring plan of a building made with two rectangles, which is what I placed in capital letters here. So the mere fact that they say that it was made with two rectangles and it's the floor, then we know that it's the area of both rectangles. So the area then, pardon me, let's grab my black ink here. Alright, so the area of, say here, the floor. I like writing words when I'm showing my calculation to the examiner. So area of floor is going to be equal to area of rec A plus area of rec B. So I'm going to call this my rec A here. I'm going to call this my rec B. and rectangle B. So area of rectangle A, area of rectangle is just simply length times width, so that's just 5.3 multiplied by 8.4. So therefore that's going to be 5.3 multiplied by 8.4. And I'm going to add all of that then to the bottom area of the the rectangle. That's 6.7 times 12.5. So that's going to be 6.7 times 12.5. 6.7 times 12.5. Let's jump on our calculator here. 5.3 multiplied by 8.4. Hope you guys are working with me. That's going to be 44.52. Ensure that you're actually working the problem before I'm doing it, so you can match your solutions with mine. And that becomes 83 point, pardon me, this part away, 83.75. So we just add back that 44.52. You're going to find that we get an area here of 128.27 squared centimeters. All right. Fantastic. Easy question there. And then now finally, as we bring into the end of this video, we have to find the area of the shaded portion. Notice that there's two circles inside the floor, so we know that the shaded portion excludes the two circles. So we're gonna have to find the area of both circles then. Alright, so then therefore then the area of the shaded portion, so area shaded portion, let's say here is area of shaded portion is area of the floor minus the area of circle A plus area of circle B. I kind of like doing this for the purpose of teaching my students, but for exam you guys could just go ahead and jump into the calculation. Already we know the area of the floor, so that's not a concern. And the mere fact that if you look back on the diagram here, you'll recognize that both circles have a different radius. The radius of the circle is 2.5, the radius of the circle is 3.2, so it makes our working out a little bit more challenging. It would have been nice if both circles had the same radius, so we could just find the area of one and times it by 2. But then therefore the area of circle A is pi r squared. So that's equal to 3.142 times 2.5 squared. Let's jump on the calculator. 3.142 multiplied by 2.5 squared. That works out to be equal to 19.63 or 64 rounded off. Let's work with that. Let's work with a round off answer. And then area of circle B is again pi r squared. So that therefore is 3.142 times the radius of that is 3.5. Let's double check. Is it 3.5? It is 3.2 in fact. So it's 3.2 in fact. Squared. Alright, so that's 3.142 multiplied by 3.2 squared. That's 32 then 0.17. So the area of both circles together, so both circles is equal to 32.17 plus 19.64. That gives us an area of 51.81 square centimeters. So those are the areas of both circles put together. So we can subtract the area of the area of both circles put together from the area of the floor. So finally then, coming to the end of this video, finally we have area of shaded portion is equal to, we had calculated it earlier. Let's see, the area of the floor is in fact 128.27. So that's 128.27 minus 51.81. So 127 point, sorry, pardon me, 128.27, take away 51.81, and we get a final area of the shaded portion to be equal to 76.46 squared centimeters. So I know that you guys are probably looking at this and you are thinking that that was a tough question. It was only tough because it required you to apply all that you've learned before. But if you safely were to be honest with yourself, you'd say that the question wasn't as challenging as you thought it was. Alright, so I do hope that you guys enjoy this particular tutorial video. I really hope that I was able to go through in details and to give you an extensive review of this particular video, this particular paper. Coming up next on the channel would be the monthly exam for my evening division, so definitely look out for that. That should be posted this Friday coming up, or this Sunday evening, one of those days. Expect to see that. And of course the end of term exam, which is going to be quite an interesting paper. I did really dig into the students' brain, to the minds of the students, so you're definitely going to want to tune in for that. And of course in December I'm going to be flooding you with a lot of review tutorials on the topics that have been taught this term. Alright, so thank you so much for watching this particular video. Do not forget to hit the subscribe button below, turn on the post notification bell, hit the like button, leave some positive questions and comments, and do not forget, guys, to share this out. If you are struggling and you're getting the help that you finally have been searching for, why not help someone else to find that help they've been searching for? Alright, lots of students fear math. I am the guru in making students' fear of math disappear. So until next time, take care, and I'll see you in another tutorial. Bye bye, guys.